All right, just a couple examples to go along with adding and subtracting numbers in scientific notation. Both these examples should look familiar because we've already written these numbers in scientific notation. So this one says we need to determine the difference of the populations of Texas and North Dakota. Texas had a population of 26 million. And so the other day, it was in our notes, we rewrote this as 2.6 times 10 to the 7th. Again, where we want it to where it is, 1, 2, 3, 4, 5, 6, 7 units to the right, and that's where that 7 comes from. North Dakota has a population of 6.9 times 10 to the 4th. Okay, so those are numbers in scientific notation, and to find the difference, we need to subtract them. So, I know it seems weird, but we're actually going to go 2.6 times 10 to the 7th minus 6.9 times 10 to the 4th. This is actually over here a bigger number because the exponent is bigger. All right, so remember, we take our smaller exponent here, 10 to the 4th, and we need to write 10 to the 7th as 10 to the 4th. So, just like we did in the other examples, I'm going to rewrite 10 to the 7th as 10 to the 3rd times 10 to the 4th. Same base, multiplying, add the exponents, and that's where that comes from. So, we get 2.6 times 10 to the 3rd times 10 to the 4th. Well, 10 to the 3rd right here is 1,000. So this ends up being 2.6 times 1,000. And if you do 2.6 times 1,000, you get 2,600. So this becomes 2,600 times 10 to the 4th. Those two things right there. Okay? Once you get there, we're just back to doing the problems like we did originally. Notice both of these have times of 10 to the 4th. So I pull out that times 10 to the 4th. Pull that out. It's like the reverse distributive property. And I'm left with 2,600 minus 6.9. So if you go 2,600 minus 6.9, you get 2,593.1 times 10 to the 4th. Now that is not in scientific notation, so this is where we have to put it in scientific notation. Let's just go back to purple. Okay. The decimal point's right here. We want it right here. If I go from where I want it to where it is, I go over 1, 2, 3 times. So I'm going to add a 3 up here. And this is going to become 2.5931 times 10 to the 7th. And that is the difference in the number of people. All right. Oops. Okay. Last problem here. Should also look familiar as we did this problem the other day in our notes, and we took our hydrogen and oxygen atoms and we rewrote them in scientific notation. So this hydrogen atom, remember, was 1.7 times 10 to the negative 27th, and oxygen was 2.7 times 10 to the negative 26th. Again, we moved the decimal point from where we want it to where it is, and I went over 27 times. From where we want it to where it is, I went over 26 times to the left, which makes it negative. All right, so if I want 2 of the hydrogen atoms, I'm going to go 2 times the hydrogen atoms. Now we write it in scientific notation, but this really means all multiplication. 2 times 1.7 times 10 to the negative 27th. Now, if you do 2 times 1.7, 2 times 1.7, we get 3.4 times 10 to the negative 27th. And we're just going to leave that in scientific notation. So now we want 2 hydrogen atoms, which we have right here, and 1 oxygen atom. And if we want the combined weight, we're going to add them together. So 3.4 times 10 to the negative 27th plus 2.7 times 10 to the negative 26. Now, just like we've been doing, and if you haven't noticed yet, the numbers are changing, but we're doing the same thing over and over. The little difference with this one is that it's dealing with negative exponents, but I still want it to be the same exponent. So I'm going to take 10 to the negative 27th, and I'm going to rewrite that as 10 to the negative 1st times 10 to the negative 26th. Same base multiplying, I'd add those exponents to get negative 27. So then I have 3.4 times that, plus, and then I still have my other part here, and that's, which isn't changing, so I'm not going to write that down yet. Now, 3.4 times 10 to the negative 1, that means we are moving their decimal point 1 to the left. And so that becomes 0.34 times 10 to the negative 26. And you can do that even on a calculator. That one step there puts us at the same power of 10 again. So just like before, I'm going to pull out that power of 10 and then just add these together. 0.34 plus 2.7. Type that into a calculator. Good news, at least on this one, is we don't have to worry about balancing it out and writing it in scientific notation, because 3.04 is a number in scientific notation. All right. All the problems we've done, guys, they have been the same thing, different numbers. So take it step by step, use your notes, and you'll get through this lesson.